Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and talk about an important topic, which is how we can improve the speed of JNI calls. And one way is to eagerly basically register native methods that we want to be linked to our Java project manually, right? So we don't wait for Java or JVM to load the dynamic library and then try to search the dynamic library to find the symbol that matches the signature of our native method. When we create the dynamic library, we manually tell the JVM what is the binding from the C++ function to the Java method. So this is called registering native methods, and JNI provides a method or a function basically for manually registering native methods, right? The native Java methods. And the way we achieve this using the JNI environment pointer, we call this function RegisterNatives. It takes the J class, which means we tell the JVM this native method belongs to this class, this Java class. So we have to pass the J class, and then we have to pass this struct, JNI native method. It's a C++ struct. It's a flat struct, and it's a pointer. Basically, it's the memory address. And then a JInt. This JInt is the number of native methods that we want this RegisterNatives to register for us, right? We can pass 1, 2, or as many as we want. But because this is a pointer that is pointing to that, so a pointer doesn't have the information about how many native methods we want, because this could be a pointer of an array of JNI native method or just the address of one single JNI native method. So we can say 1 or 2 or whatever, right? So we should also specify how many, this pointer points to how many of these native methods that we want to register. So this JNI type, JNI native method, we typically call it NM, native method, right? This is this is a something that is very similar to a Java method handler, right? What we need to specify, it carries the information about the name of the Java method, the native method, the signature, and the function pointer. And that's what this function pointer property is what working with registering natives makes it more easier and more user friendly, at least in my opinion. Because then we basically what happens here is that, so we create this JNI native method, and then we set the name. It takes a char array. Char pointer is just a C++ style string. This is the name of the Java method, but the name of a method is not enough to uniquely specify which Java method we are talking about, because Java allows method overloading, which means not only the name is important, but also the signature of the parameters is important if that method is overloaded. And again, by signature of a method, we mean it's a parameter signature and then the return type. So the parameters are in round brackets, and after that we have to specify the type of the return value. But then this is the important point, function pointer, and this is a C++ function pointer. So far we've been running a Java Edge tool, and it creates the function signature for the native method, and it was like Java underscore package name underscore class name. And when JNI loads the dynamic library, and when we call a native method, JVM goes and looks into that dynamic library, tries to find a signature, a symbol that matches the signature or the JNI signature of that method. But here, this way, when we specify the function pointer, this doesn't need to actually have the signature of Java underscore package name underscore class name underscore method name underscore parameter signature if it's overloaded. It doesn't need. This is just a pointer. It tells the JVM, take this C++ function pointer, and whenever I call this Java method that has this name and this signature, just go and call this C++ function. This is it makes life much easier, right? As we will see when we go to the Eclipse. So this is called eager linking. So basically, as soon as the dynamic library is loaded, we also manually tell JVM where is the C++ binding to this Java method that has this name and this signature. And this function pointer, it's a C++ function pointer, that's actually the C++ binding, all right? And then another benefit that is very obvious here by specifying manually specifying the C++ binding to the Java method is that when we use basically the traditional way, which is creating the Java underscore package name underscore class name underscore method name, we mentioned that these functions should be in the global scope in our C++ project, because otherwise JNI won't be able, JVM, when it loads the dynamic library, it won't be able to find the signature, the symbol, right? However, because here we are manually specifying the function handler or the function binding, this could in fact be inside any namespace in C++. So there is no limit here. We just have to point the JVM to this C++ function, right? So it doesn't have to be in the global scope or anything like that. We don't have any limitation here. So JVM just have to be able to find it, and we are manually pointing the JVM to where this function pointer is, this function is, right? It could be inside any namespace. So JNI functions must be in the global scope, and this applies to the bindings that the JavaX creates, Java underscore package name underscore class name underscore method name. And obviously the exception is anonymous namespace, because anonymous namespace doesn't, in a CPP file, it doesn't create a new scope. We can call them without any scope. Function pointers, like here, function pointer, don't need to be in the global scope. They can be inside any namespace, and it doesn't cause any problem because we are manually telling the JVM where to find it, right? So this is called eager linking, and JVM obviously by default uses lazy linking, which means when it loads the dynamic library, it doesn't look into it until we call a native method, right? So when we call a native method, now it goes into that loaded dynamic library, tries to find the symbol that matches the signature of the Java method, native method that we want to call, and then goes and calls that, does the linking or binding of that symbol inside the dynamic library to that native method in Java. Now obviously this saves some overhead, because if we load a huge dynamic library and we never call use any of the native methods, then JVM is more relaxed in that case. But when we do eager loading, we do the work at the beginning, right? JVM loads the dynamic library, and then it already knows how the binding works, which Java methods correspond to which C++ functions. Okay, so we already ahead of time tell the JVM how this binding happens. So when a dynamic library is loaded by JVM, it won't link because it waits until we actually call a native method, right? Until a native method is actually called. Then JVM goes and searches inside that a dynamic library. But when we manually do this kind of binding and tell the JVM where the symbols are, JVM doesn't really need to do any search inside the dynamic library. So why RegisterNatives functionality is very useful? No need to use JNI naming convention. So this is the first usefulness of this approach. We said that if we use Java H tool to create the signature of that Java method in C++, the convention is Java underscore package name underscore class name underscore method name, right? And this should always be in the global scope. Otherwise, the JVM won't be able to find this symbol when it loads the dynamic library. But now, because we are manually telling the JVM that where the function pointer is, it doesn't, and this function pointer corresponds to actual function in C++, and that function doesn't need to follow this naming convention because it doesn't have to. Just JVM knows, okay, this is the pointer, the function binding to this Java method, so I just go and call it. However, we have to be careful because again, the parameter list is still important, and we'll talk about it in the next slide. So this is very useful when trying to reuse already existing C++ source codes or libraries, because then if I have a C++ source code that already has some functions and I just want to bind them to a Java method, those functions don't need to follow this naming convention. So this is very good. So the first usefulness is that we don't need to follow this convention, which sometimes ends up being a very long name for the C++ function. Although because Java Edge creates it, we don't really care. It's not that much hard to work with it because Java Edge creates it. But in general, if we can make the C++ function names simpler, that's appreciated. The other thing is that now if we go with this approach and manually register the native methods, we don't need to have all these C++ bindings in the global scope of our C++ project. We can put them in namespaces and point the JVM to that function inside that namespace, which might be useful in some cases. All right, so extremely useful feature. We can use functions inside C++ namespaces, as I mentioned, because we're just manually telling the JVM where the function is, all right? And then therefore, we can write some create standalone static C++ libraries for JNI and reuse them in different JNI projects. All right. So as we said, no need to have JNI calling convention for the function. So for this function pointer, it doesn't have to have this sort of naming, Java underscore package name underscore class name underscore method name. However, the parameter signature is still important because when we tell JVM, okay, this Java method that has this name and this signature binds to this C++ function, JVM already knows which parameters to pass to this function. So JVM says, okay, I know where the pointer is for this function. I go and call that function. But the first two parameters that JVM tries to pass to this function is exactly what happens in a normal JNI call. The first parameter is always JNI environment pointer that we call it JVM. The second parameter, again, is either a J object or a J class. So if this function, C++ function, binds to a instance method in Java, then we have to pass a J object. If it binds to a static method, we have to pass a J class. So JVM, when JVM knows the name, the function pointer, the C++ function pointer, it always passes these two parameters by default, right? So let's say if I have this function in some C++ source code that takes an integer and just doubles it, I have to manually modify the signature to have these two parameters as the first two parameters, right? We have to must add them, otherwise JVM won't be able. Just specifying the function by function pointer by itself is not enough. We have to make sure that the first two parameters are the JVM and then the J class or J object, depending on whether it's binding to an instance method or a static method, all right? So here's a very simple example. I have this test30 package. I have a person class. It loads the dynamic library and immediately registers all the native methods inside these classes, inside this class, right? Right now, I just have one native method. So this RegisterNatives, it must have the signature that the JNI expects, but for the other one, know that I don't have another Java underscore package name underscore class name underscore method name. I just have this one. I call it double it. And I want to register this function as the binding to this native method, a static native method in Java, right? So all we have to do, we have to have one function, which is RegisterNatives, and that's the convention that we use. It's a static native void method called RegisterNatives, and we always follow this convention. And in this RegisterNatives, it has to have the JNI convention for naming, Java underscore package name underscore class name underscore method name, which is RegisterNatives, and it's always a static, so it takes the JVM pointer and a J class, which is the calling class in this case. And now we don't need any other function. All we have to do, we have to manually create the binding of these Java methods to C++ function. So I create a JNI native method. I create a JNI native method. I call it double age underscore method because this method called double age, all right? And then it's a struct, has a name, signature, and function pointer. So the name, I say it's double age. A string literal is const char pointer. I convert it to a char pointer, right? So this is the name of the Java method. And what is its signature? It takes an integer and returns an int. And now I have, so this is telling the JVM which Java method I'm talking about. I want to bind it to, I want to do the binding for which Java method. And now JVM knows that, okay, this binding happens for this double age method, all right? And then the function pointer is the important one, and it expects any type of the function pointer, which means a function that can return any type, which means it could be a void pointer, right? Because the return type is not important. JVM figures it out. And we know that in C++, the name of the function is actually a function pointer. So I can either do ampersand, double it, the name of the C++ function, to get its address, or I just say double it and it automatically converts it to an address, right, that points to this function. So yeah, but I convert it to void pointer because this function pointer doesn't care about the actual return type of the basically function, so it's a void pointer. Function types are basically void pointer, right? And then I call this RegisterNative function from JVM RegisterNatives, and now I created this method binding that binds the Java method to a C++ function pointer. Now I need to tell the JVM, okay, this method resides in what class? Remember that when we specify the name of the method, we don't specify it as package.class.method name, right? We don't do that. We just, it's a plain a string of the name, whatever the actual name of the method is. We don't specify the class or the package. That comes from this parameter. The first parameter to RegisterNatives is a J class, which means this method belongs to which class, right? And J class knows where this class is on the class path. So it knows the package, it knows the name of the class, all right? So we say that this method binding happens for this class, and this is the address. We have to give a pointer to this method binding, so it's an address of the method, and we have to specify this block of memory corresponds to how many method bindings. So in this case, it's just one, all right? So obviously what you can see here is that if I add another native method, I don't need to update any header file anymore. All I have to do, I have to copy and paste these 4 lines and then give the name of the other native method, give its signature, give its function pointer, and then register it. So that's very good now because I don't need to keep updating and updating header files if I add more and more native methods. So let's head to Eclipse and try to have a look at this. In Eclipse, I have created this package, test30, and I have created the person class as always, and I have this class test RegisterNatives. So in the person class, I'm loading the dynamic library because I have native methods, and I call this private static native void RegisterNatives. And this is a convention that I strongly recommend for you to always follow. You always have this RegisterNatives. So don't use any other name like RegisterNative methods, or just use RegisterNatives. And then it's always private static native void. So this is my strong recommendation to use this convention. All right. And then I'm going to start with one native method. So obviously I have to take the steps that I usually take to create a header file, but I don't need to add any native method and generate the header file because I only need to create a header file for this RegisterNative, right? Because then if I add more native methods, I can manually specify their signature in the RegisterNative in C++. So basically, if I don't add this native method, I just add this one static native void RegisterNatives and then run the Java Edge tool. On this class, it creates a header file for me, and it's called a test30%, and it just has one method, right? Java underscore package underscore class name underscore RegisterNatives. And it has the JNI environment pointer, and because it's a static method, this RegisterNatives is static, I get a J class reference. And then I create a CPP file. Let's call this what is the name that I RegisterNatives.cpp. Okay. And then I have this I have copied and pasted this function Java underscore package class name underscore RegisterNatives from the header file. And I want to basically, when this is called, I want to register all the native methods that I add to this function, to this class. So again, I don't create any header file or Java binding with this type of naming, Java underscore package name underscore class name underscore method name for all the native methods. Instead, I manually register them when this RegisterNatives is called, right? And this is the power that we have here. So so maybe let's put this side by side. All right, and let's go full screen. So what I'm going to do, so I create this JInt, this function, I call it double it. So I intentionally chose a name that is different from this Java method name. And what I want, I create a JNI native method here, double age underscore method. This is this JNI native method type, which is a simple struct that has a char pointer as a name, char pointer as a signature, and void pointer for a function. And we are basically manually describing the Java method and describing it binds to which C++ function. All right. Okay, so what happens here is that I say, okay, I create this on the stack, double age underscore method dot name. It's the name of the Java method is double age, right? And then its signature is that it takes an integer and returns an integer. And what is the binding? The C++ binding, this native method binds to which C++? So it's function pointer, it's a void pointer. I say it binds to this function, double it, right? That's it. And then I say register natives. This register this native for this class, person class. Note that because this register natives is called from within the person class, I have a reference J class that is actually J class of this class. If I didn't have a reference, I have to ask person class. I have to ask JVM to find this class on the class path, right? So I have to tell it it's in the test30 underscore it's slash person. So I have to manually find it on the class path, but in this case it's not needed because this J class parameter is actually a J class reference to the person class. So I already have it. And then this register natives takes a JNI native method pointer. So I have to pass the address of this struct JNI native method, and then I have to also specify how many native methods I'm registering. So n methods, number of methods is just one, right? So this is how we do it. And then I can immediately compile and build. It builds fine. And then copy and paste the dynamic library to my Java project. All right. And then if I go to this test register natives, I'm just let's put it on this side. I just call the person dot double age and pass in 5, and this should return 10. Note that I don't have anything like a Java underscore package name underscore class name, which is person underscore method name double age, right? I didn't create any of these. All I had to do, I had to implement this register natives, and I am manually binding this native method to the function C++ function that I want it to bind, right? So it's very easy because now if I add more native methods, I just immediately can bind them, and there is no need to update any header file or run any JavaH again and again to update the header file. So let's try this. So I have this person double age 5, and it should return 10 to me. Yes, 10 is returned. And now let's go back here and let's create another method. So let's say int let's say double or maybe void, and let's say hi, and it doesn't take any parameter. It's still a static native void say hi, and I don't need to update any header file or run JavaH anymore. So all I have to do here, so I registered the first one, I can register the second one. So let's call this say hi method, and let's copy and paste the name. It doesn't take any parameter, and the return type is void. So we don't specify the void, the capital V for the parameter type, but we have to specify its return type as void, right? And then it's function pointer. So ignore these for now. So what I'm going to do, I'm going to create a void let's say hi implementation, right? And again, we have to always pass these two parameters, JNI environment pointer and either a J class or a J object. So there is no way around it, because even though we tell JVM which function to call, we doesn't tell it which parameters to pass to this function. So the JVM assumes that it always needs to pass a JNI environment pointer and a J class or a J object, right? So we have to always add these two to the actual implementation. And I want to write something to the console, so let's include the IO stream, and we're going to say that std cout hi from C++ with RegisterNatives. All right, so it doesn't take any parameter, returns void, so the signature matches, and then say hi impl, and we are going to register it one more time. So from person class, now we pass the address of these, and we are just registering one again. All right, so let's build this project. It builds fine. Let's copy and paste the dynamic library. Okay, now let's go back here, and then let's call our native method. So person.sayHi. And hopefully this is going to work without any problem. Let's run it. And as you can see, hi from C++ with RegisterNatives. I don't know why I added this one. So let's quickly build it one more time. And then copy and paste the dynamic library. And then run this one more time. Yes, now it works. Again, the main benefit is that when we add more native methods, we don't need to run JavaH again and create these kind of JNI names or bindings, which starts with Java underscore package name underscore class name underscore method name. Especially if the name of the method is too long or it's overloaded with very parameters, then we don't care about the overloading and stuff, right? So this way of registering natives is very powerful, and I always recommend you to go with this route. Always have this register natives, and this has a very interesting benefit that I'll talk in the next lecture, and that's, remember in the early lectures I mentioned that when we use JavaH and create the header file, the name of these C++ bindings is tied to the basically package name and class name, and refactoring Java code causes problem, and basically it breaks this symbol name. Now with register natives, if we go and eagerly load our or basically eagerly bind our Java methods to C++ functions, there is actually a very nice way that we can ensure that refactoring any of the Java classes won't break the C++ binding, and that's the most powerful concept. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.